The National Electrical Code, or NEC, permits the use of a white wire as a neutral conductor in a 480/277 volt system. However, using a grey wire for the neutral is a recommended practice for clarity and safety reasons. While not a strict NEC violation to use a white wire, there are several benefits to adopting the grey wire as the standard for neutral conductors in 480/277 volt systems. Firstly, a common practice among electricians is to use a grey wire as the neutral conductor in 480/277 volt systems. By adhering to this convention, you reduce the likelihood of confusion for electricians who may work on the system in the future. Consistency in wiring practices is crucial for maintaining safety and efficiency in electrical systems. Secondly, a grey wire can help prevent confusion between the neutral conductor and other conductors in the system, which can reduce the risk of electrical accidents. Especially in complex electrical installations, distinguishing between different conductors is paramount to avoid miswiring and potential hazards. Thirdly, using a grey wire can make it easier to identify the neutral conductor when troubleshooting the system. When electrical problems arise, being able to quickly and accurately identify the neutral conductor can save time and effort in diagnosing and resolving the issue. While the NEC permits the use of a white wire as a neutral in 480/277 volt systems, it's important to understand the nuances of the code and the best practices within the electrical industry. The NEC is a comprehensive set of guidelines designed to ensure electrical safety. It's important to consult the latest edition of the NEC for the most up-to-date information and requirements. There are specific sections within the NEC that address the identification and use of grounded conductors. NEC Section 200.6 states that an insulated grounded conductor of 6 American wire gauge or smaller shall be identified by a continuous white or grey outer finish or by 3 continuous white stripes on other than green insulation along its entire length. This section explicitly allows for either white or grey as acceptable colors for identifying the grounded conductor. However, NEC Section 200.6 addresses situations where conductors of different systems are installed in the same raceway cable, box, auxiliary gutter, or other type of enclosure. In such cases, one system grounded conductor, if required, shall have an outer covering conforming to 200.6 or 200.6. Each other system grounded conductor shall have an outer covering of white with a readily distinguishable different colored stripe other than green running along the insulation, or shall have other different means of identification as allowed by 200.6 or 200.6. That will distinguish each system grounded conductor. This section aims to prevent confusion when multiple systems share the same enclosure. It's crucial to understand the difference between a courtesy violation and a code violation. A code violation is a direct contravention of a specific requirement outlined in the NEC or other applicable standards. A courtesy violation, on the other hand, refers to a practice that, while not explicitly prohibited by the code, deviates from industry best practices or common conventions. In the case of using a white wire as a neutral in a 480/277 volt system, it falls into the category of a courtesy violation because the NEC permits it, but using a grey wire is the preferred and widely adopted practice. There are several compelling reasons to prioritize the use of grey wire for neutral conductors in 480/277 volt systems, even though the NEC allows for white wire. Firstly, consistency in wiring practices promotes safety. When electricians consistently use grey wire for neutrals in high voltage systems, it reduces the likelihood of errors during installation, maintenance, and troubleshooting. Secondly, clear identification prevents accidents. In complex electrical installations, distinguishing between different conductors is essential to avoid miswiring and potential hazards. Grey wire provides a clear visual cue that helps electricians quickly identify the neutral conductor. Thirdly, streamlined troubleshooting saves time. During troubleshooting, being able to quickly and accurately identify the neutral conductor can save time and effort in diagnosing and resolving electrical issues. Grey wire simplifies the identification process, making troubleshooting more efficient, while the NEC allows for the use of white wire as a neutral in 480/277 volts systems. It's important to consider the potential benefits of using grey wire as the standard practice. In addition to the reasons mentioned above, using grey wire can also help to improve the overall professionalism and appearance of an electrical installation. When all neutral conductors are consistently identified with grey wire, it creates a clean and organized look that reflects attention to detail and adherence to best practices. The decision of whether to use white or grey wire for neutral conductors in 480/277 volts systems ultimately depends on a variety of factors, including local codes, client preferences, and the specific requirements of the project. However, it's important to weigh the potential benefits of using grey wire against the potential drawbacks of using white wire. In many cases, the advantages of using grey wire outweigh the disadvantages, making it the preferred choice for neutral conductors in high-voltage systems. There are also some specific situations where using grey wire for neutral conductors is particularly important. For example, in industrial settings where electrical systems are often complex and subject to frequent maintenance, using grey wire can help to minimize the risk of errors and accidents. Similarly, in healthcare facilities where electrical reliability is critical, using grey wire can help to ensure that the system operates safely and efficiently. It's important to note that the NEC is not the only source of information on electrical wiring practices. Many other organizations and publications offer guidance on best practices for electrical installations. These resources can provide valuable insights into the latest trends and techniques in the electrical industry, and they can help electricians stay up to date on the latest codes and standards. Some examples of organizations that provide guidance on electrical wiring practices include the Institute of Electrical and Electronics Engineers, the National Fire Protection Association, and the International Association of Electrical Inspectors. These organizations offer a variety of resources, including publications, training courses, and certification programs. In addition to consulting with industry experts and reviewing relevant publications, it's also important to gain practical experience in the field. Working under the supervision of experienced electricians can provide valuable hands-on training and help to develop the skills and knowledge necessary to perform electrical work safely and effectively. Practical experience is essential for understanding the nuances of electrical systems and for learning how to apply the codes and standards in real-world situations. It's important to remember that electrical work can be dangerous if not performed properly. Always take the necessary precautions to protect yourself and others from electrical hazards. Wear appropriate personal protective equipment, such as safety glasses, gloves, and insulated footwear. To energize circuits before working on them whenever possible, and use lockout/tagout procedures to prevent accidental re-energization. Follow all applicable codes and standards, and consult with a qualified electrician if you have any questions or concerns. By following these safety guidelines, you can minimize the risk of electrical accidents and ensure that your electrical work is performed safely and effectively. In summary, while the NEC permits the use of white wire as a neutral conductor in 480/277 volt systems, using grey wire is a recommended practice for clarity, safety, and consistency. Adhering to industry best practices and conventions, such as using grey wire for neutrals in high-voltage systems, promotes safety, prevents confusion, streamlines troubleshooting, and enhances the overall professionalism of electrical installations. Always consult the latest edition of the NEC and other relevant resources to ensure compliance with applicable codes and standards. Remember to prioritize safety in all electrical work and seek guidance from qualified professionals when needed. Understanding the nuances of electrical codes and best practices is essential for ensuring safe and efficient operation of electrical systems. Continuous learning and practical experience are crucial for staying up to date on the latest trends and techniques in the electrical industry. By embracing a commitment to excellence and safety, electricians can contribute to the reliability and integrity of electrical systems in various settings, from residential buildings to industrial facilities. The selection between white and gray wire for neutral conductors in 480/277 volt systems highlights the importance of understanding not only the letter of the code but also the spirit of best practices within the electrical profession. While the NEC provides a baseline for safety, experienced electricians often go beyond the minimum requirements to enhance the overall quality and safety of electrical installations. This includes considering factors such as ease of maintenance, future expansion, and the potential for confusion among different systems. For instance, in a large commercial building with multiple electrical systems such as lighting, HVAC, and life safety systems, using different colored wires for the neutral conductors of each system can help to prevent accidental connections or misidentification during maintenance or repairs. This can significantly reduce the risk of electrical hazards and downtime. Similarly, in industrial facilities with complex machinery and control systems, using consistent wiring practices can simplify troubleshooting and reduce the likelihood of errors. In these environments, even a small mistake can have significant consequences, so it's essential to minimize the potential for human error. Furthermore, the choice of wiring practices can also impact the longevity and reliability of electrical systems. For example, using high-quality conductors and connectors can help to prevent corrosion and ensure a secure connection over time. Proper grounding and bonding techniques can also help to protect against electrical surges and other transient events that can damage equipment and disrupt operations. In addition to the technical aspects of wiring practices, it's also important to consider the aesthetic impact of electrical installations. In many commercial and residential settings, exposed wiring can be unsightly and detract from the overall appearance of the space. Using concealed wiring methods and neat, organized wiring practices can help to create a more professional and visually appealing installation. This can be particularly important in high-end residential projects or commercial spaces where aesthetics are a priority. Ultimately, the goal of any electrical installation is to provide a safe, reliable, and efficient power supply for the intended application. By carefully considering all of the factors involved, from code compliance to best practices to aesthetic considerations, electricians can ensure that their work meets the highest standards of quality and professionalism. Continuous learning, practical experience, and a commitment to excellence are essential for success in the electrical profession. By staying up to date on the latest technologies and techniques, and by always striving to improve their skills and knowledge, electricians can make a valuable contribution to the safety and well-being of their communities. And it is with a deep and broad understanding of the NEC guidelines that anyone can thrive in their work. This ensures that any electrician will be performing the work in a safe and efficient manner.